This unit is going to cover high availability, and the first subject for high availability is going to be network load balancing, or NLB, using Microsoft Windows Server. So in this slide deck, I'm going to talk about configuring network load balancing and configuring a failover cluster, which are both handled by the same service in Microsoft Windows 2012. Now, before I get started here, getting into too much depth here, basically network load balancing, and I think I've got a picture here. There we go. So network load balancing is basically when you have a single virtual IP listening for traffic on the wider network, not the wide area network, but the entire network, and then it sends that traffic to servers that are all running the exact same thing. So in this example here, you see we have three servers on the right-hand side, .2, 3, and 4, and presumably each one of these would be providing the same service on the network, and they can use a shared virtual IP address. Now, there's two ways you can do this in the Microsoft Windows world, and one of them involves using Windows services and the other one does not. So when you take a network security class or a networking course, you probably also learn about clustering and load balancing, but using a device or an appliance to do so. So that little device that you see here in this picture, that's a switch, because it's no different than any other switch where all of the computers are connected to a switch. And what happens is the three computers running Windows clustering services or network load balancing each are able to listen on that same virtual IP, so they all can listen on the same 10.12.1.100 address, but they each also have their own IP address to communicate with one another. And the idea is that they share information between each other so that they can figure out who's going to respond to which requests coming from which servers, or which clients on the network. The other way you could do this is, instead of having Windows listen on the virtual IP, instead you give an appliance a virtual IP and it handles routing the traffic to the correct servers. Now, I will tell you that in the industry, in the field, probably the much more common way to do this is going to be using an appliance, using a network load balancing appliance to do this, and not doing it natively in Windows. You may be wondering why. I mean, if Windows can handle this natively, why not just use Windows to do this? And you're going to see throughout this presentation that it is not a simple task to set up network load balancing in Windows. There's a lot of requirements, and everything has to be set up just right for it to work. And there's ways to do this with other platforms too. Linux has support for the same functionality here, but it's so much easier to set up because, as you're going to find out, in Windows, everything has to be configured exactly the same way. They have to have the same versions of software. They have to be sharing a SAN on the back end. So there's a variety of reasons that doing this is not always it's not always the best way to do it using Windows. But it is important to understand that you can do this, and I want you to be aware that this is something you have in the toolbox when you're working in the field. But I just wanted to preface by telling you I'm going to go through some of this a little bit quickly, because I think in the real world you're probably going to be more often using load balancing switches, such as a Barracuda F5, Cisco or something like that sits in front of your Windows servers to do the clustering. It's a much more elegant way to do it for sure. So basically, network load balancing is available as a service in 2012 Data Center and Standard editions. It does not have any special hardware requirements, but it's important that each server in the cluster is configured with the same OS version and updates. So you have to have the same operating system version. All the Windows updates have to be the same version. Everything has to be identical. And the servers participating in the cluster shouldn't provide services other than the ones the cluster is providing. So you can't really have any other services that are going to be listening on that other IP address, like the .2, 3, and 4 that you saw on the previous slide. So that's also, everything has to be kind of set up just right, as I said before. So the network load balancing must be installed on each server in the cluster. So the network services to be load balanced must be installed and configured identically. Nothing can be different. They all have to be configured the exact same way. The cluster should be configured with two NICs. One NIC is going to be for communication with network clients. So that's going to be the NIC that has the virtual IP. And then the other NIC is going to be for the cluster members to communicate with one another. So that's going to be that .2, 3, and 4 address that you saw on the previous slide. So network load balancing is installed to the feature and server manager, just as we've installed, in other parts of the course. You've seen how to do that. You're just going to select the network load balancing feature in order to do the installation. So it's pretty straightforward. So again, here's that picture, but augmented now to show you that the 3 servers also have to be in a dedicated network for communication on the back end. So it's generally best practice to have them on a different switch. Now here we show 2 different switches, but in reality, when I've done this, we just use VLANs. So you take the one switch and you create a VLAN for the cluster communication, and then another VLAN for the rest of the network where the virtual IP is going to sit, where they plug in, they jack into the switch with the virtual IP. So creating a load balance, a network load balancer cluster involves the following steps. You're going to create a new cluster. Then you're going to select a new host and network interface to participate in the cluster. And then configure the host priority and host ID, which I'll talk about in a few minutes. Set the cluster IP address, which is the virtual IP that we talked about. Then you're going to set the cluster name and operation mode, and configure your port rules, which define which ports you're going to accept into the cluster. For example, if you're running a IIS cluster, you're probably going to use port 443 and port 80, for example. Then you're going to add servers to the cluster. So you define which servers are going to be members of this cluster. So to create a network load balancing cluster, you're going to open the network load balancing manager from the tools menu in server manager, just like we do with from everything else. Everything's from the server manager. So you're going to create a new cluster. This is the first step. So when you create the new cluster, you have to specify the host to participate in the new cluster. So you're going to enter the server name for the first host in the new cluster. Then after the load balance manager is connected to the server, you're going to ask to be select the network interface the server will use in the cluster. So you're going to choose the interface to be used to communicate with client computers that access the cluster. So not the cluster communication, but this is for the client side communication. This is where the virtual IP is going to be listening. All right, so each participating host is assigned a unique host ID, which is also the host priority in the cluster. And you can have up to 32 servers in an NLB cluster, and they can have a priority value from 1 to 32. The cluster member with the lowest priority handles all cluster traffic not associated with a port rule. So you can override this if you like. Okay, so the virtual IP address is the address that the network's client used to access the network services provided by the cluster. So a DNS host record, so you have to make sure you set up a DNS host record for the cluster IP. So you're going to need an FQDN to point to, so an A record on the FQDN for the virtual IP that you're going to use for your cluster. So if a single NIC, if you're using a single NIC, the cluster IP address is added to the NIC's TCP/IP properties, but that's not the recommended way to do this. It's much cleaner if you use 2 NIC cards. So if you use 2 NICs, then the cluster address replaces the current address to the NLB NIC. So again, it's a little better if you have 2 NIC cards rather than having 1. You can do this with 1 NIC card, but it is better to have 2 NIC cards. All right, so setting the cluster name. We're going to cluster name and operating mode are set in the cluster parameters dialog box. So the cluster name is the FQDN that clients are going to use to access the cluster. So that's going to be the full internet name in the text box. And the cluster operation mode specifies the type of network addressing used to access the cluster. Your options are unicast, multicast, and IGMP multicast. Unicast is usually the best way to do this. That's the default option. But you could use multicast as well if you're only using 1 NIC. But again, it's usually recommended. In my experience, it's a little more reliable if you use unicast with the secondary NIC rather than having 1 NIC and using multicast. So there's the options in here. And like I said, unicast is going to be the default. Hopefully you have more than 1 NIC card when you do this. It's definitely worth it to have more than 1 NIC. Gosh, I think it's even hard to buy servers anymore with just a single NIC card in it. So the port rule is how you're going to specify the type of UDP and TCP traffic that the cluster is going to respond to, and how it's distributed between the cluster members. In other words, the load weight, how much of the traffic is going to go to server 1 versus 2 versus 3. So you can, and sometimes we call that affinity, so the affinity of the traffic. So with traffic distributed proportionally based on the load weight of the other members, that's what we're talking about with load weight. So the higher the load weight, the more traffic that the member handles. So you can tweak the amount of traffic that each member is going to receive. It's generally best practice with the port rule to only allow the ports in the cluster that you're using for the services being offered. So you would only do port 80 and 443, for example, if this were for web services. So you're going to add servers to the cluster in the NLB manager. You're going to right-click in the cluster and then add a host to the cluster. This is how you create new nodes in the cluster. The feature must be installed on the server that you want to add. So every single server that's going to be participating in the cluster has to have the network load balancing feature added. You don't have to go through all these steps on each one. You just have to have the feature installed in order for it to work. and you have to select the network interface that the server will use for communication with clients, and you have to assign it a priority between 1 and 32, as we discussed earlier. So after you have at least 2 servers in the cluster, you can then go further in the configuration, because once you have at least 2 servers, you can officially have a cluster. Without, with a single server, there's really no point in having a cluster. It's just a single server. So configuration of the cluster is divided into 3 categories. We have the cluster properties, the port rules, and the host properties. So let's talk about each one of these. So the cluster properties. So if you right-click on the cluster in the Network Load Balancing Manager, you will see the cluster properties. So the cluster properties are going to include the IP address and some other cluster parameters, which we're going to discuss. And then the cluster IP address is set when you create the cluster, and you can change the cluster IP address using that tab. So you may want to assign more than one IP address to a cluster when it's running multiple instances of the same service. So there's the screen where we add the IP address, and that's the same one from our from the diagram that you saw in the beginning of the slide deck. So the cluster parameters that are configured in the Parameters tab, they consist of the following. You'll have an IP address, a subnet mask, the full internet name or FQDN, a network address, and the cluster operation mode. We're going to talk more about cluster operation modes here in just a little bit. But port rules, before we get into that, port rules basically are how you configure which ports you're going to allow for the cluster, or which ports it's going to respond to. And as I said before, it's better if you only allow the ports that are actually being used by the cluster. So you can change that range to a range that's appropriate for the ports that are being used for the cluster. By the way, you can have multiple rules, so you could do a range of 80 to 80 and then 443 to 443 in different rules. So the options for filtering mode are multiple host. The traffic on specific hosts is load balanced between all cluster hosts, or single hosts, where the host with the highest priority handles all the traffic on the specified ports. So the affinity rule is none. So any cluster member can respond when you have no affinity. Single is when requests from a same client are directed to the same cluster host. And network, which is a single cluster host, responds to connections coming from a specific IP network. So, and this is one of the challenges with network load balancing is that, let's say you're a client and you, let's say you're a web browser and you're using a web application that uses sessions, right? So the problem is when you create a session on server number 1, your session exists in server number 1. Let's say you log into a web app. Let's say it's your webmail, right? Like Exchange webmail or something like that. If you log in on server number 1, your session exists on server 1. The next time some traffic is sent to the cluster, if you end up on server number 2, you no longer have that session because server number 2 is not aware of your session. So the affinity value of single means that once you connect to a server, for a period of time, it will keep the traffic stuck to that server. Now, the disadvantage here is if that server goes offline, you may experience some downtime, but the alternative is you would be losing your session all the time. So it makes sense. And this capability is available even if you use an appliance. So this isn't, you don't have to use Windows to have that feature and that functionality. This would work with any load balancing configuration that uses a real, an appliance in front of Windows. So don't think you have to have Windows in order to do that. All right, so there's our host properties. So we right-click under the cluster name to click into host properties, and we'll get this dialog box where we configure the host parameters. So under host properties, you can set the cluster IP address tab, shows the cluster's IP address. The parameters tab shows you the cluster parameters, but you can't change them in this tab. You need to open the cluster's property dialog box to change those. And if you use port rules tab to edit port rules that aren't set to disabled mode. So here we can edit some port rules. So to manage a cluster, if you need to perform maintenance tasks on the cluster, you can change the state of hosts in the cluster as a whole. In other words, you can bring down a, let's say you have to do some maintenance on one of the servers. Maybe you have to replace a hard drive or something like that. You can pull it out of the cluster. That way you can work on it, and then when you're done, you can bring it back into the cluster. And this is really the whole point of clustering is zero downtime, right? If you have 5 servers contributing in a cluster, you can bring down 2 of them if you wanted to, right? You could theoretically bring down 4 out of 5 and your cluster is still running. Just like a 747 can fly on one engine. It's got 4, But if 3 of them die, you're still flying. Same idea with network load balancing. If something goes down, we're still online. Users are none the wiser. They don't even know that it's gone down. And you can see here in this example, it looks like this particular person is using port 23. So they're probably doing, 23. I think that's Telnet. But either way, that's basically how it works. You can pull things out of the running for network load balancing, and then you can bring it back in when you're done working with it. So if you need to upgrade your cluster, so for example, you have to upgrade the operating system, you have to upgrade each host one at a time and then bring the cluster back online. So you could take the entire cluster offline, upgrade all of the servers one at a time, and then bring the entire cluster back up. Here's the problem with network load balancing with Windows is you can't have different operating systems running within the cluster. They all have to be the exact same version for this to work, and the same version of the NLB feature. So there is a way to do a rolling upgrade where you take each cluster node offline, you upgrade it, and then you bring it back online, and it should maintain uninterrupted access to the cluster services, but not all applications will support that. So it depends on whether it's supported. Again, using a third-party network load balancing device kind of takes all the complexity out of this. It doesn't even matter when you do that. So before performing an upgrade, you have to keep the following in mind. You want to verify that all the services are supported on the new OS, which you would do anyway with anything. You're going to use the drain stop option for each host before you begin the upgrade and set the initial host state to stop. And then after finishing the upgrade, you're going to verify that everything works correctly before you bring the host back into the cluster. So you're going to make sure whatever service you upgraded or whatever you've done, it still works after you've completed the upgrade. Otherwise, bringing it back into the cluster is going to cause some issues. And like everything else, we have some PowerShell commandlets that you can use to manage the clusters, in addition to using the UI, which we've just talked about. So those are also available. All right, in the next slide deck, I'm going to talk about configuring failover clusters.